Hello, and welcome to our discussion on debugging like a pro tips and strategies. Today we're going to peel back the layers of this essential process in programming, debugging. Now, you might be wondering, why is debugging so crucial? Well, it's simple. Debugging is the cornerstone of creating flawless code. It's the process that allows us to identify and fix errors, enhancing the performance of our software. Without it, we're left with code that's riddled with bugs, leading to a poor user experience and potentially even system failures. In this video, we'll cover everything from the basics of debugging, common issues faced during programming, the role of debugging in software development, to understanding the issue and analyzing the problem. We'll also introduce you to popular debugging tools, how to break down complex code, and the importance of keeping track of your debugging process. So, brace yourself as we dive into the world of debugging. Before we proceed, it's crucial to understand what debugging truly means. Picture a detective hunting for clues. Debugging in programming is just like that. It's the process of finding and fixing issues or bugs in a computer program. Now, these bugs could be anything from simple syntax errors to complex logical issues that cause the program to behave unexpectedly. Every programmer, regardless of their level of expertise, encounters bugs. They're like the unwelcome guests who show up uninvited to your party. Whether you're creating a simple application or building a complex software system, bugs are inevitable, and debugging is the broom that sweeps them away. Debugging is not just about fixing the problem, it's about understanding why the problem occurred in the first place. It's about stepping into the shoes of the code, tracing its path, and uncovering the truth. Now that we have a clearer understanding of debugging, let's explore why it's so important. Debugging plays a pivotal role in software development. Let's delve into why. You see, debugging is not just about fixing an error, it's a process of detective work, uncovering the root cause of problems in a program's code. Inadequate debugging can lead to a variety of issues. It can result in software that is riddled with bugs, which can disrupt user experience and tarnish the reputation of your product. It can also lead to inefficiencies in the code, causing the software to run slower than it should. The cost of fixing these issues escalates the longer they remain undetected. It's much like finding a needle in a haystack. The earlier you start looking, the quicker you'll find it. So, it's crucial to debug thoroughly to ensure a smooth and optimal software performance. Hence, understanding the problem is the first step towards effective debugging. A problem well stated is a problem half solved. And this couldn't be truer when it comes to debugging. Before you dive into fixing code, it's crucial to fully understand the issue at hand. Picture yourself as a detective trying to solve a mystery. You need to gather all the clues and analyze the evidence before you can pinpoint the culprit. So, how do you do this in debugging? Start by reproducing the error consistently. If you can't replicate the issue, you can't really solve it. Next, isolate the issue. This means narrowing down to the specific code segment causing the problem. Use print statements or breakpoints to observe the program's behavior. Remember, it's not about quickly finding a solution, but about thoroughly understanding the problem. Faulty fixes can lead to even more complex issues down the line, so take your time and approach it systematically. With a good understanding of the problem, the right tools can make the debugging process smoother. There are several debugging tools available that can make your life much easier. Let's dive into some of the popular ones. Visual Studio Debugger, for instance, is a favorite among many programmers. It allows you to step through your code line by line, inspect variables, and even modify the state of your program on the fly. Another powerful tool is Chrome's DevTools. This tool is especially useful for web developers, as it helps you inspect HTML, modify styles, and diagnose performance issues. Then there's the classic print statement. While it may seem rudimentary compared to other tools, don't underestimate its power. Sometimes, the simplest methods can provide the most insight. How about a quick demonstration? Let's say you're using Visual Studio Debugger. You've hit a snag in your code. Just set a breakpoint, run your program, and voila! You can now step through your code, inspect variables, and get a clearer picture of what's happening. Understanding your code is vital when using these tools. Complex code can seem daunting, but breaking it down can make it manageable. Whether it's a labyrinth of nested loops or a sea of conditional statements, complex code can feel like a riddle wrapped in an enigma. But don't panic just yet. Imagine it as a gigantic puzzle. You wouldn't try to solve it all at once, right? You'd start by sorting the pieces into smaller, manageable groups. Similarly, breaking down code into smaller sections can help you identify and isolate the problematic parts. Start by identifying the parts of your code that are working as expected. This can help you narrow down the areas where the problem might lurk. Once you have a suspect, you can isolate that section and probe it further. Remember, Rome wasn't built in a day, and neither will your bug-free code. It's a process, and each small victory brings you one step closer to your goal. Keeping track of your process can prove invaluable in the long run. A log is a programmer's best friend. This isn't just a catchy phrase, it's a fundamental truth in the world of coding. When you're deep in the debugging trenches, it's easy to lose track of what you've done, what you've changed, and what still needs to be fixed. That's where a log comes in handy. A well-kept log is like a breadcrumb trail leading you back through your code. It documents your steps, your thought processes, and your problem-solving strategies. It helps you avoid revisiting the same issues and keeps you focused on new ones. But the benefits of logging don't stop at the present moment. A comprehensive log becomes a valuable resource for future debugging. It provides insights into past problems and solutions, and it can even offer clues for tackling new challenges. So as you navigate the complex maze of code, remember to keep a log. It's your map, your guide, and your memory all in one. Remember, there's no shame in asking for help when you're stuck. Debugging can sometimes be a team effort. No one, not even the most seasoned programmers, knows everything. There can be moments when you're stuck, and that's perfectly okay. It's crucial to recognize when you are spinning your wheels. If you've tried different approaches, consulted the documentation, and you're still not making progress, it's time to ask for help. Reaching out for assistance doesn't mean you've failed. On the contrary, it's a testament to your dedication to find a solution. Be clear about what you've tried, where you're stuck, and what you don't understand. This allows others to provide targeted, effective help. Collaboration is a key aspect of programming. It's not just about solving a problem, but also learning from others, expanding your knowledge, and enhancing your debugging skills for the future. So don't hesitate to ask for help when you need it. Now, let's summarize what we've learned today. Let's round up the key points we've discussed today. We started by unraveling the essence of debugging, casting light on its role as a vital aspect of programming. It's more than just fixing errors. It's about understanding the flow of your code, identifying problems, and honing in on solutions. We underscored the importance of debugging in software development. It's not an option, but a necessity. Inadequate debugging can lead to software teeming with bugs, causing user frustration and potentially damaging your reputation. Next, we explored the importance of thoroughly understanding the issue at hand. To debug effectively, you need to be able to analyze the problem, break it down, and isolate the problematic code. This is where debugging tools come in handy. They help you step through your code, monitor variable values, and ultimately pinpoint where things are going awry. We also delved into the process of breaking down complex code. It's like solving a jigsaw puzzle. You need to isolate the parts, understand their role, and then see how they fit together. This can be an arduous process, but it's crucial for effective debugging. Keeping track of your debugging process was another key topic. Maintaining a log of your steps and solutions is not just useful for future reference, but it also helps you think systematically and avoid repeating mistakes. Finally, we talked about knowing when to ask for help. Debugging can be a solitary task, but remember, collaboration can often lead to faster, more effective solutions. Don't be afraid to reach out to your peers, mentors, or the online programming community. We've covered a lot, but there's always more to learn. So, feel free to share your own debugging tips and strategies in the comments. Let's learn from each other and continue to grow as programmers. Remember, debugging is an art that improves with practice. Keep coding and happy debugging.